In this class, let me give you an interesting problem based on electric field. The problem says a positive point charge plus Q is kept in the vicinity of an uncharged conduction plate. Vicinity of an uncharged conduction plate. Sketch electric field lines origination from the point onto the surface of the plate. Point charge onto the surface of the plate. A positive point charge plus Q is kept in the vicinity of an uncharged conduction plate. Sketch the electric field lines origination from the point charge onto the surface of the plate. So this is very interesting. Let us try to solve this. So before solving this, let me give you a note. When we have a conductor, so how these electric field lines pass through this conductor? So the note is important. So the first one is, so this is a note. So before solving, you should know this note. The electric field lines do not pass through the conductor. When you have a conductor, the electric field lines will not pass through the conductor. Electric field lines do not pass through the conductor. This is because field line inside the conductor is always equal to 0. Because field inside the conductor is always equal to 0. So another point is the field lines just outside the conductor are normal to its surface. This is very important. Electric field lines just outside the conductor are normal to its surface. So this is a note. So what are these means? Now if you have a conductor, So the field lines will not pass through the conductor. It will be like this. The first point says the field lines do not pass through the conductor because field inside the conductor is always equal to 0. Now the second point says electric field lines just outside the conductor are normal to its surface. So if you have the field lines passing like this, so when they fall on this conductor, they will be normal to its surface. So wherever they are touching, no, they should be normal to that point. So we know the field lines end at negative charge. So they fall normal. So at this point, wherever they are touching the surface, they should be normal to that surface. Something like this. So then they go straight here. So this point you have to note. After that we can solve this. Now we will take up this problem. A positive point charge plus Q is kept in the vicinity of an uncharged conduction plate. Sketch the electric field lines origination from the point charge onto the surface of the plate. So remember this second note to draw this. Electric field lines just outside the conductor are normal to its surface. So for this conduction plate, whatever the field lines are falling, they should be normal to its surface. Now the problem says a positive point charge plus Q is kept in the vicinity of uncharged conduction plate. Now we have an uncharged conduction plate. Uncharged conduction plate which is placed near a positive charge plus Q. Now we have to mark the, so this is the arrangement. Now positive is plus Q is kept in the vicinity of an uncharged conduction plate. Sketch the electric field lines origination from the point charge onto the surface of the plate. So this is the initial arrangement. A plus Q is placed near an uncharged conduction plate. Now what will happen? So because of induction, the opposite charge get attracted towards this plus Q. So remember, a body can be charged by conduction, induction and friction. So here the mutual induction takes place and opposite charge induces on the surfaces of the conductor near to the source charge. So what will happen is plus Q I'll draw a little bit down so that I can mark the field lines clearly. So we have the uncharged conduction plate. So plus Q will attract all the negative charges to this side. Positive charges will be on the other side. So the charge of opposite nature induces in the surface of the conductor nearer to the source charge. So this is due to induction. Now we know that, so if you take only the positive charge plus Q, so how do we mark the field lines? So field lines will move away from this positive charge. Let us mark these field lines. So now these field lines will be moving away from the positive charge. And whatever the field lines falling on the conductor will be at 90 degree to its surface. So they will start here and end, so that when they fall they will be normal to the surface. Something like this. And on the other side they move away from the positive charge with normal to the surface. So this is how you have to sketch. Remember, due to induction, the opposite charge gets induced on the surface of the conductor nearer to plus Q charge, and when the electric field lines fall, they fall normal to the conducting plate. So similarly, if we have two positive charges, how do we mark the field lines? Electric field lines for two positive charge. So plus Q and another plus Q is here. So in this case, the field lines are marked like this. In case of two positive charge, the lines will be moving away from this. So two positive charges placed close to each other. We know they repel each other, and the field lines, remember the properties of field lines. So they are marked like this. So in case of two positive charges, the field lines are marked like this. Similarly, if I have a positive charge and a negative charge, so plus Q and minus Q. In this case, the field lines start at positive charge and end at negative charge. Field lines start and end at negative charge. So this will move away from negative charge. So this is how we mark the field lines. So they all will be moving. Sorry, here they will be ending at negative charge. The field lines end at negative charge. They start at positive charge. This is the field line when we have one positive charge and another negative charge which are placed close to each other.